Today we're going to be talking about domain and range. When we talk about domain, what we're talking about is all of the possible x values that can be used for that function or relation. And similarly, when we talk about range, we're talking about all of the possible y values that can be used. You're going to see two types of notations when it comes to domain and range. One type is set notation, and the other type is called interval notation. And both of these notations have different symbols that are used to represent things. In set notation, now we've actually looked at this part before, we've got the curly brackets, and this just denotes a set of something. And in this case, we're going to be talking about a set of numbers, or a set of x values, or a set of y values that are possible for domain and range. You're also going to see this symbol, which looks kind of like a 1 or an L. It's just straight up and down. It's a little bit taller than an L. And this represents the words such that. And I'll explain that further as we go through some more examples. You could also see this symbol, like a fancy E, and that is used to represent element of or belongs to. And you might see something like this. This fancy R represents the set of real numbers. And you can have other fancy letters that denote other sets of numbers. You might have different symbols that denote the set of integers or the set of complex numbers, although that's beyond the grade 11 curriculum, or the set of natural numbers or the set of whole numbers, etc. The set of integers, you might see that one. So we'll talk about those as they come up in certain examples, but the one most often used is the set of real numbers. In interval notation, you might see some different symbols. You might see what's called open brackets or the round brackets, and this indicates that a particular value or a number is not included as part of your domain or range. You could see what's called closed brackets or the square brackets, and this indicates that a particular value is included as part of your domain or range. In interval notation, you might also see this symbol. And this is used to indicate the concept of infinity. Okay, so here's one example of a relation. We'll determine in a minute if it's a function or not. So we've got the 0.2435, 4, 6, and 5, 7. Okay. Taking a quick look, this is indeed a function because for every x value, there's only one associated y value. We don't have any duplicate x values in this relation. And if we were to look for the domain, and I'm just going to use D to signify domain and R to signify range. The domain we know is all possible x values for this relation. Now in this particular relation, we've only got 4 different x values that are possible. We can use the x value of 2, 3, 4, or 5. And so those 4 numbers make up a set of numbers. So in set notation, we would use curly brackets to signify a set. We would just say that we're looking at the set of numbers of 2, 3, 4, and 5, and then we're going to close that bracket. For the range in set notation, again, it's a set of numbers, so we're going to use the curly brackets to denote that. And here we're looking at 4 possible values, 4, 5, 6, and 7. So we're going to put that in our curly brackets to say that that is the set of numbers that represents all the possible y values for this relationship. Okay, so this is set notation. Now, for this particular example, we don't really look at interval notation because for interval notation, we need some kind of continuous x or y values that are being used, whereas here we have very specific x and y values being chosen. Okay, this is our relation, and we know that a line is indeed a function based on the lessons we've done already. Think of if we had the equation for this line, then any x value that we substitute in, we could get a y value. And so the domain and range for this line are actually going to be all real numbers, right? Because in addition to being able to substitute in -8, -7, -6, we can substitute in all the integers, but we can also substitute in all the decimal values and all the numbers in between those integers. So I can substitute in an x value of 2.5 and get a corresponding y value. Okay? Or I can substitute in an x value of 1/3 and get a corresponding y value. And so because of this, in set notation, our domain would be listed as, and we're going to use that curly set of brackets, and inside that curly set of brackets, we're going to say that our x values belong to the set of real numbers. And this is the special notation that I was talking about with the special symbols. So this E represents, remember, element of, right, or belongs to. And we say here that X belongs to the set of real numbers, or X is an element of the set of real numbers. Now the range in this case is going to be the same because we can get any Y value based on what X value we substitute into the equation or on the graph. So here we're going to use the letter Y. Our Y values belong to the set of real numbers. Now, in interval notation, it looks a little bit different. So for interval notation, we're going to use the concept of the open bracket. We're going to list that as x is an element of, and you saw that up here as well, negative infinity to positive infinity. So all numbers in between that. Now for infinity, we automatically use the open bracket. And we're going to see some other examples where we use the closed or the square bracket. But when we're using infinities, we're always going to use open brackets. And the range is going to be similar, but this time y is an element from negative infinity to positive infinity. And we're done. All right, here's another example. Here we've got a circle with radius of 4, and we're going to do the domain and range in both set and interval notation. Now, in set notation, we know that our possible x values, we could use an x value of -4 all the way up to +4. We can use any x value in between that range because if I pick an x value of -2, I've got y values that are associated with that. Now this circle, in fact, is not a function, but it is a relation. So any relation we can write domain and range for. Now, inside that range from -4 to +4, I can use any x value there, but I can't use any x values that are outside that range. So an x value of -6 is not going to give me any y values corresponding to it. Same for the y values. I'm restricted to any y values between -4 and +4. Anything in between there is okay, but anything outside, I don't have any corresponding x values for those y values. So for set notation for the domain, I know I can go from -4 to +4, so that's going to be in here somewhere. We're going to start out with, again, the set of curly brackets, and I'm going to start out with, now this looks a little funny, but x is an element of real numbers. And then there's that line, there's that such that line, remember that one? Okay, and this means that after this line, we're going to list some conditions that have to be true because x can't be all real numbers. X is only a certain set of real numbers. X is going to be all real numbers between -4 and +4. So I'm going to say x is greater than or equal to, because it could also be equal to -4, -4. And at the same time, x has to be less than or equal to +4. You really have to know your greater than or less than symbols here to do domain and range. And then we're going to close that curly bracket. Okay. Similarly, the range, the y values also have to be between -4 and +4. So we're going to say that this time y is a real number such that, or these are the conditions, y has to be greater than or equal to -4 and less than or equal to +4. So anything between those two values for y is okay. Now, interval notation, again, looks different. For interval notation, we're going to say that the x values can go from -4 to +4, and we know that the comma indicates a particular range of numbers. So we're going to say -4, comma, +4. Now in this case, we want to include those endpoint values because -4 is a value that we can use for the domain, and +4 is a value that we can use for the x values. So we're going to use closed brackets here because we want to include those two endpoints. And then in front, we're going to write x is an element of. So we know that x is somewhere in this range of numbers. The range, again, is similar. And this time we're going to have y is an element. And again, the range of numbers we're looking at is from -4 to +4. And we want to include those two values. All right, here's another example, and again, in both set and interval notation. Now, for this one, we know that the possible x values will go from -3 to +5. We want to include this value of +5 because on this graph, when that point is closed in, that means that that point is included. And we want to not include this value of -3 because when the point is open on the graph like this, not colored in, that means it is not included. So we need to make sure that we are identifying that in the notation that we choose to use. So for set notation, again, we know that our x values are any real number in between -3 and +5, not including -3, but including +5. I'm going to start out with x is any real number such that, and I'm using that any real number part because we can still use any value in between here. Anytime you have a continuous line or curve on your graph, you're usually going to see this x as an element of real numbers part. And I'm going to go from -3, I'm going to have the x in the middle, and then the +5 on the other side, and then I'm going to close the brackets. We just have to decide what symbols go here. So I want x to be greater than, but not equal to, so I'm not going to put that line on the bottom, -3, and x is going to be less than or equal to +5, so I'm going to include the line there. For the range, in this case, y can actually only be one number. So I've got a couple of options here. I could write that as simply the number 3, or I could write that as y is an element of real numbers such that y is equal to 3, although this is a lot of extra writing for just having one value that is possible for y. So this one is probably recommended. For interval notation, same idea. I know that my x values that are possible go from -3 to +5. I'm going to say x is an element, and I'm going to use the range of numbers from -3 to +5. I want to include the +5, so I'm going to do a square bracket there. And I want to not include the -3, so I'm going to do an open bracket there. The range, again, we know is only the one value, so we don't usually do that in interval notation because we're looking for a range of numbers, but you could list that as just the value 3, like this, in closed brackets because we're including that 3. Okay, here's another example, and the scale is going up by 1, so I'm going to label it on here for you. 1, 2, 3, 4, 5. In this direction, 1, 2, 3, 4, 5. And the negative numbers are the same scale. Okay, again, we're going to use both set notation and interval notation. And I'm going to start with interval notation first this time because I think it's a little bit easier to work with. So for the domain for interval notation, all possible x values. So here, we're going to start from the left and move to right, and that's going to help us with our domain. So for the domain, we've got x is an element of. Okay, now we're actually going to have two pieces to this because I'm going to do this first piece, but then there's a break because this line here means that x can't actually be that value of 1. I'm going to write that here. X cannot actually equal 1. X can equal any value up to 1 or above 1, but it cannot actually equal 1. This line is actually called an asymptote. We're going to talk more about that in future lessons. So that asymptote means that the function or the relation approaches that line but never actually touches or crosses it. So when we look at the domain here, we're going to start with this first piece. We're going to be starting at negative infinity, so I've used the open bracket for that. And going up to, all the numbers are good up until we get to 1. So I'm going to say up to 1, but we don't want to include 1 because that asymptote means that we don't. Now I'm going to write this symbol. This U represents union. And this is what you're going to use when you want to join two pieces of a graph together for the domain or range. So here we've got two pieces on the graph that are separate. We're going to link it using a union symbol in the domain and range. So after that, we're going to start again after 1, not including 1. So I'm going to use the open bracket up to positive infinity. And again, open bracket there because we always use open bracket for positive infinity. The range is similar, okay? But this time, we've actually got an asymptote here at y is equal to 0. And so y cannot actually equal 0, but it can equal any value below 0 or any value above 0. So we're going to incorporate that into our range. So y can be any value from negative infinity, we're going to start at the bottom this time, negative infinity up to 0, but not including 0, so open bracket. And then the second piece, we're going to start at 0, so it can be any value up to 0, above 0. So start at 0 and go up to positive infinity. All right, so that's interval notation. Set notation for the domain, we know x can be any real number, and then we're going to set some conditions on it, but we know x cannot equal 1. So we're just going to say x can be any real number except for 1. So that's all we need in our notation. And our range is going to be y is an element of real numbers, except for what's the value y cannot equal. Y can't be 0. So there's domain and range in that notation. All right, what about this one? What if we are given an equation instead of a graph? Let's say we have the function h of x is equal to the square root of x minus 9. Okay. Now, we could talk about, first of all, why is this a function? If you're not sure how to graph this, which we're going to be learning very soon, if you're not sure how to graph this yet, you could use a table of values to graph and pick x values to generate the y values and get some ordered pairs. Or we can simply think about, what does this operation mean, the square root sign, and what does that mean in terms of the values of x and y that we could use, or the values of x and y that are possible. So what values of x are possible for this operation? Well, we know that for square root, we need to have a positive value under the square root sign. So we want x minus 9 to be greater than 0. Now, can it be equal to 0? Yes, because we can take the square root of 0, and that's equal to 0. So what we want here is we want all the x values that are greater than or equal to 9. Because if x is equal to 9, we get 0. If x is equal to 10, we get 1. So any value greater than 9 will work for x. But anything less than 9, if you have 7, for example, we're going to get -2 under the square root sign, and that won't work. So we want the x values to be greater than or equal to 9. So in terms of the domain for this function, in set notation, we want all real numbers, but they have to be the real numbers that are greater than or equal to 9. Okay? Now the range, well, if we plug in an x value of 9, which is on the lower end of this set of numbers, plug in an x value of 9, we're going to have 9 minus 9, which is 0. Square root of 0 is 0. So y could be equal to 0. That's a possible y value for our range. If we pick any x value greater than 9, we're going to have an answer that is greater than 0, because 10 minus 9, for example, if we take the square root of that, we get 1. So we're going to have numbers that are greater than or equal to 0 for the range. So here we're going to have y is any real number, but the y values have to be greater than or equal to 0 in order to work.